So yeah, welcome to AWE. It's great to be here for the very first session, and it's actually my first AWE ever. Actually, I was due to come a few years ago, but then airline strikes made sure I couldn't. But yeah, so as Remy said, I was at Unity for a long time as the head of evangelism for Europe. So I've done many of these types of talks where we go live in the editor and show people how to get started with a certain platform. I joined Magic Leap about 5 months ago now because I really saw the power of mixed reality, and I really wanted to focus on one type of device, one type of ecosystem, and mixed reality and Magic Leap really stood out to me. So now I am part of the developer relations team in Europe. So if you are a developer, if you do want to get started with Magic Leap, this is the correct talk for you, and do come see me afterwards. We also have a few of my colleagues here, a part of the enterprise sales team. So if you are an enterprise organization, come chat to us afterwards. And we've got a few devices, so come by for a demo. I'll be around on the show floor all the time, so feel free to grab me whenever. So yeah, so today we're going to talk about developing for Magic Leap. So this talk is going to be almost live in Unity in the editor, showing you how to get started as a developer in Magic Leap. So I've got a device here. I'm going to be using our Magic Leap remote and a thing that we call zero iteration, so constant iterating in Unity and deploying to the device. So we're going to go through spatial meshing, we're going to go through controller input, eye tracking, hand tracking, and different poses that you can do on the device, and then some of the best practices. And yeah, going to do all of that in hopefully 53 minutes and 987 seconds. So let's get started. If you want to reach out to me, Naylor at Magic Leap, and on Twitter, Josh Naylor. Please feel free to take pictures and post them so I can retweet and show what an amazing job I am doing. So yeah, so Magic Leap. So it was released just over a year ago in the US. And again, the reason that we're here, that they hired me in Europe, and there's more people coming over to Europe from our US team, is because it is more accessible as a device in Europe now. So yeah, again, please do come chat to us. It's a mixed reality spatial computing device. Full 6DoF, fully contained, inside-out tracking, and a 6DoF controller. And a lot of people go to us, what does that actually mean? What does mixed reality mean? What does spatial computing mean? So this is one of the diagrams I like to show. So we've got virtual reality, VR, and this is where you are shut into a full digital world, right? It means that there's nothing of the real world around you, you've got a headset on, and you could be in your living room or sat on your toilet. Then we've got AR, which is obviously augmented reality, and this means that digital content is laid on top of the real world, but doesn't actually interact with it. It's not spatially aware. It doesn't actually fit sometimes the context what you're in. And this is where mixed reality, or spatial computing as we call it, kind of comes into play. This is where digital items, digital content interact with the real world around you. So what I'm going to show soon is building up a full demo where I can pull objects into the space around us, and if I drop a cube, it will land here. If I drop a cube in front, it will land here. Then I've meshed like the first 3 rows of people here. So I've got these humanoid figures in front of me that I can place cubes on top of your heads. Again, it's interacting with the real world by building up this real-time spatial mesh. And this is the hardware itself. So we've got the lightware. So this is a pretty light device. This is where all the sensors are based, obviously. And then we've got the thing that we call the light pack. So this is a quad-core CPU. It's got an NVIDIA Tegra GPU in. This is where the power, the battery, the storage is all stored. And then we've got the 6DoF controller. For me, this is like the best thing about the whole device, is having a 6DoF controller as a self-contained device. It just means that you can interact with objects so much better than using hand tracking all the time. Obviously, it becomes very fatiguing if you're doing it for a long time. And it just gives you that so much more control, having a trigger, bumper, and a full 360 touchpad with swipes, radial, anything like that. So yeah, there's a bit more information about the specs there. So what can it do? What can we use to interact with with digital objects in the physical world? So the very first thing, and the most simplest thing, is actually using the head pose Obviously, this is a full 6-DoF track device. So understanding where the user is moving the head pose, position, or orientation, you can interact with digital objects. And this is a really big thing for accessibility. Obviously, yeah, we've got hand tracking, we've got a controller, we've got eye tracking, but just having the accessibility for 6-DoF control is really great. Next, we have gestures and hand tracking. So we've got 15-point hand tracking on both hands simultaneously, as well as 8 predefined gestures as part of the SDK. So these gestures are things like open hand, front and back, L, index finger, OK, pinch, C, and thumbs up. So all of those, it's just a simple call into the API, which I'm going to show soon. And I said full 15-point hand tracking. Image tracking, like you would have with mobile AR devices. So just point the device at an image and it recognizes that. Eye tracking, so this is just a vector-free position that you can call into your API and say, where is the user looking? Am I looking at this digital object? And again, I'm going to show you how to set that up pretty soon. Full 360 audio, as you would expect. So you can either use Bluetooth audio, you can use just normal input into the light pack, but then also we've got speakers just inside of the headset here. So it gives you different opportunities depending on what you want to give to your user. But yeah, full 360 spatial audio as part of our own SDK. Multimedia, so you can connect via Bluetooth to mobile devices, you can connect it through Wi-Fi, obviously, and you can play and stream audio back and forth. And the biggest thing is what actually makes it mixed reality and spatial computing is world reconstruction. So how we can, in real time, move around an environment and it stores this spatial mesh in our scene and builds it up. So, what are the types of applications that we can build with it? It's basically 2 different types. We've got landscape applications and we have immersive applications. Landscape applications are what we call like passive applications. It's where you can have multiple open applications at a time. So as you can see here on this left image, we've got a living room here, we've got this nice bonsai tree in the middle, we've got the Dr. G robot hanging by the sofa, and then we have like a video streaming device such as Netflix or Now TV or YouTube on the wall. And this means that all of these are placed in bounding volumes or prisms, and this right now you can only build through our Lumin SDK runtime. Immersive applications are very similar to what you would expect from mobile AR or VR applications, where this is a full immersive application that just opens up by itself and near enough all of the device resources running into that application. So this is where you're using full spatial meshing, you're using controller input, you're basically spending 90% of your active brain capability on just this application. Where the other ones are more passive, it might be a calendar, it might be Skype, it might be watching a video. So the first thing I want to talk about, the experience that we've developed so far, is this. It's called Create. So as you can see, this is a demo of all the assets in Create, and Create is made by Magic Leap Studios, our first-party studio based in Florida. So this was an idea of how can we onboard people into spatial computing and make them understand what it is. So here's a really quick video of what you can do. And you've got all these like small little nights and forests and biomes. You've got alien UFOs flying around. And you can put them in your space. And it's a full sandbox environment that you can spend literally hours. I've spent hours in this just playing around with how they interact with each other. You've got little knights that you see that fight each other. You've got the UFO that attacks the aliens. You've got a flying turtle that you can put the UFO on, the astronaut on. You've got this dinosaur, and everything is interactable and just gives somebody who's never used a mixed reality device, a Magic Leap device, just an understanding of some of the capabilities that you can do with it. So everything's physics-based. It bounces off the walls, off the floor, off your table, and again, it just kind of immerses you in that world. So when the team was developing this, they kind of thought like, this is the kind of environment where you might be in your living room, you might be in your office. What kind of like childlike wonder, what kind of magical moments can we give to users? So they went through like, what is magical to kids? What engages kids? So we've got dominoes in there, we've got flying fish, we've got these lovely biomes like a coral reef and a forest. We've got building blocks like Lego where all the pieces snap onto each other. And that's what it was like. What they wanted to do is create these small moments that we call wow moments, where you're playing with a device, you're playing with this new technology, and oh wow, that's really cool. And you have like 10 of those every time. Every time I show someone through it, they're like, oh yeah, that's really sick. So part of this application was the accessibility, so making it easy for people to use, because it's going to be their first time probably using a mixed reality Magic Leap device. Allow for exploration and also expression, allowing them to kind of, because it's a sandbox, you can do anything you want, and then educate them on mixed reality and spatial computing. And then the next thing is, when you're like educating people, you have to make it a comfortable and safe experience for them. So that's why we picked these super small little characters, very cartoony-esque, and made it more authentic because of that, because people like looking at those kind of cartoony things. Again, it brings like that childlike wonder back. So, if you want to get started, we've got the creator portal, so it's just creator.magicleap.com. This is where we have loads of tutorials, loads of documentation, best practices for design as well. And this is where you can get all of the SDK tools, our package manager, and then publish onto Magic Leap World, which is our platform within the OS that you can download all the applications from. So right now, you can register as a developer, individual or enterprise, and you can build applications and deploy them to the store. And then we also have this other section called concepts, and this is more for smaller, more prototype R&D applications where people may be jumping into mixed reality, spatial computing for the first time, and they want to get it onto the store for people to look at. And this is where we have a separate section of the store called concepts. Cool, so getting started as a developer. What you'll need is the Lumen SDK, the Magic Leap Unity package, and Unity 19.1 or above. So you'd get this from the package manager. So you go onto Creator Portal, you download the package manager, and this is where everything for you as a developer is stored. So we've got the Lumen SDK, the Unity or Unreal packages, and then also all of the extra documentation, device stream to stream the device from your laptop or computer, all sorts of stuff. This for me is great. So like I spoke about earlier on, this is the zero iteration Magic Leap remote. So whether you have a device or you're sharing a device with your teammates, you can use the simulator or you can use it straight into the device, which I'm going to show you how to do. Because Magic Leap and the whole ecosystem is based on an Android flavor, you've got your general kind of Android-like tools like Magic Leap Device Bridge, and we build MPKs instead of APKs, so it's all very similar if you're an Android developer. So that's all the PowerPoint stuff sorted. Let's jump into Unity and show you how to get started. So this is the kind of application or thing that I want to make. So if I check my device on here, what I've done is scan the room. So I've scanned maybe the first 3 rows, all of the area around me. And this is the package manager. So what I want to do is I've got Lumen SDK installed already. I've installed all my Unity packages. I've brought them into Unity. And I'm going to go Magic Leap Remote and launch Magic Leap Remote. And again, this gives me 2 options, whether I want to go into the simulator or I want to go straight into the device. I have my device here plugged in. I'm going to go and start device. And within a few seconds, it's going to hook up to the device. It's going to allow me to press play in Unity and demo straight away into the editor. That's connected. It's brought up my interaction panel, but I don't need it because I've got my remote, I've got my headset. I'm going to press play in Unity. And live demos are always scary the very first time you press play. There we go. So you can see in the Unity game view the mesh that I am creating as I walk around, as I scan my area. You can see some humanoid figures. I can see my controller. I can see my raycast. So you can see when I'm pointing into the distance. Let's make that maximized. Where's my mesh gone? Let's try again. There we go. So we can see I've scanned you here. I've got my raycast, so I'm either shooting far off into the distance or it's interacting. I'm going to press this object here. I'm going to launch these cubes. I'm going to pick them up. I'm going to scale. And I can place it on your head. And it's going to fall, because it's all physics-based. So this mesh I just created in real time as I press play. So I can scale these objects, chuck them to the back. And as you can see, where I've not done a mesh, it's just going to fall forever. Goodbye. So I'm going to show you how to build this all from a fresh, brand new scene. So let's start a brand new scene in Unity, Control-N, save. We've got completely fresh, brand new scene. We've got a main camera directional light. We're going to remove our main camera because that's just a standard Unity camera. And I've pulled in the Unity package that I got from the package manager. And I'm going to search just for camera. And this gives me a new main camera. So I'm going to pull this in. This has got all of your standard XR stuff, such as the tracked pose driver, which handles the headset into the main camera, as well as this Magic Leap camera scripts. And this scene optimizer with this really amazing tick box that says, fix problems on startup. Never untick the box. So now I could press play, and you can see it's going to be working. What I'm going to show you is I'm going to turn off zero iteration to the device and launch the Magic Leap simulator instead. So imagine if you didn't have a device, if you want to get started as soon as you get home tomorrow, or if you've got a team where you're all sharing limited devices. The next thing I'm going to use is a thing, I'm just going to search for mapper and bring in this Magic Leap spatial mapper. So this is where all the magic happens. It's all done for you. There's no messing around. It's this one easy prefab that's called spatial mapper, and you can say, hey, what's my settings? I want to change my level of detail of my meshes to be high or low. I want to change it to be triangles or a point cloud. I want it to be whatever you want. So you can change everything there. It's all customizable, but it's super easy to get started straight away. Go back to my Magic Leap remote again, and I'm going to press Start Simulator. So it's going to launch a new user interface for us, which looks very similar to Unity, you might notice. And this is the Magic Leap simulator. So I've got my scene view kind of thing, my eye view, and all of my properties, such as my head pose, left controller, right controller, eye tracking, touchpad gestures. I'm going to load in a virtual room. So these all just come pre-packaged with the remote. I'm going to launch couch room, for example. And you can see we've got this virtual room here. So that's launched. That's hooked up to Unity. I can press play. And now we're going to see that, like I did before, where I press play and it scanned the room, it's going to build up this room. I'm going to start rotating around. And let me move this across for you. You can see in the game view, it's showing the mesh that it builds up. In the eye view, it's showing the mesh on top of the actual scene. So that's exactly what I saw. I saw all of you in the room, but with a mesh on top of you. And then in the scene view here, it's building up this mesh. So this is what it actually does in Unity. So you can see it's built up this mesh here. And if I click on, say, for example, the table, this mesh is now as though it's just a normal asset that you pulled in from your normal DCC tool, such as 3ds Max. So it's got a mesh renderer on, it's got a transform, it's got a collider on, and it's got our wireframe shader on. So this is literally no different if you pulled in an asset from from anywhere else, from the asset store. And that's kind of the power of using a 3D game engine with the device, because now I can do anything I want as I would do normally in Unity. So as you can see all of this mesh data that's built up around the room. So all of these are individual meshes. So if you did want to optimize, you could probably merge all the meshes depending on the size of them, depending on the vertices. You can combine them at runtime, whatever you want. Different applications actually do different types of meshing. They either do real-time runtime throughout, or for Create, for example, because it's a very large application, you're going to be pulling in a tremendous amount of assets into it because it's a sandbox. What this actually does is guide the user at the very beginning of the application to scan their room, and it bakes that mesh in place. So I would say walk around this entire room, I would mesh it, and then I would bake that mesh in place. So if anything changes, then it won't be updated in the spatial mesh, but that's by design. I could continuously run it at all times. I could see people walking past. I could scan people if they stood still for too long. If you moved furniture around, it would remesh that furniture. So again, it completely depends for you as the user, as the developer, of what you want your users to do and how they interact with the spatial mesh. Cool. So that's how good the simulator is. Obviously, you've got all of your inputs here, eye tracking, input controller. You can do everything there. But because I have a device with me, it's much easier to show straight. Let's cancel that. Straight into device. Cool, so as you've seen so far, all I've got is a directional light, my main camera, and my Magic Leap spatial mapper. So when I press play now, it's going to do exactly what you've seen before. So I'll press play, and it'll build up this spatial mesh around me. So when I go into the editor, in the scene view, I can zoom in, and I can see, especially you two here. Cool. So this is just our standard wireframe mesh. What if you want to have your own mesh? I've got some pre-made assets here, one called dots. And this is, again, all part of the SDK. We've got the shader called Magic Leap Basic World Space. So I'm going to go in my Magic Leap spatial mapper. I'm going to go to our mesh prefab, which is called Original, and I'm going to replace this with the other mesh object. There we go. And I'm going to create a new empty game object, call this my mesh parent. Always remember to put it as 0, 0, 0, because then your mesh is offset. I was having trouble with that last night in my hotel room. I was like, where the hell is my mesh? And I realized it was like 10 units off into the distance. I'm going to make sure that it's always spawning to mesh parent. I don't want my hierarchy filled up. I'm going to press play again. And again, using this 0 iteration, you can just see how quick you can start developing. So now everyone's dots. So it looks a bit more like point cloud data, I guess. And you can have, this is just literally, I grabbed an image off Google. And you can do that. So you can make your mesh whatever you want it to be. I've seen stuff where people do some nebula, which looks amazing. I've seen it where people put donuts. I've got donuts on here that you can do. So there's our mesh. But we actually want to interact now. We want to place objects into the scene. We want to add controller input. So I'm going to search for controller, and I'm going to pull in this controller prefab. And again, everything's done magically for you. Yay. So we've got controller connection handler, we've got the controller visualizer, and the controller transform. So again, I'm going to press play. And then my controller is going to be connected, and I can see my controller in the world. Lovely stuff. What do I want to add now? I'll say let's add a a raycast from the controller that dynamically scales with the world. So wherever I point my raycast and it hits a mesh, I want it to scale. So let's add a new game object and call this controller beam. And again, I've got a pre-made script, which is super simple. That's called beam. And I'm going to pull in my controller. And this is super simple. It's a raycast that's basically saying, hey, add a line renderer to this object. Raycast from my controller. If it hits something in the world space, scale it to this point. What we should be able to see now is we can see this raycast that goes really far off into the distance. When I move it down to hit you in the head, I'm sorry, it scales dynamically. So it's super easy as a user to select exactly what I want. And I could just do that all day, just point at your head. Cool, so we want to place something in the world now. So let's pull in a cube. Let's place it in the world. It's going to have physics attached to it. Let's do, say, place objects. And I want to place this pre-made object that kind of looks like a Mickey Mouse cube head. It's got transform on. It's not got much on. Let's press play. So what I'm telling the controller to do now is when I press my bumper button, I'm going to press my bumper. It's going to place the object on top of the mesh where my raycast hits. And it's just going to place it there. And wherever I place it, because it's got physics attached to it, but it's not going to place it if I shoot off into the distance. It's only going to place where I tell it to. Let's pull in these. That's great. Let's fill our world with Mickey Mouse donut heads. And you can see how quick I am iterating into the device. So yeah, this script, I wasn't going to do any live coding. I've tried that before. It doesn't work. There's always a missed semicolon somewhere. So super simple. I'm saying start the Magic Leap input. I want to get my controller on button down, so just calling the Magic Leap controller ID. If it's the bumper, which is our button here, raycast down, place the object, and that's all fine. And then update my beam with the controller transform. Super simple. What do we want to do now? So we've got spatial meshing, we've got controller input, we've got the controller tracking, we've got our dynamic beam, we've got placing an object. I actually want to pick up my object and move it around and scale it with my controller. So like I've said before, we've got our bumper here, which is just attached to the button. We've got a trigger here, which is a value between 0 and 1 as a float. And then we've got this 2D trackpad. So you can get a value between 0 or minus 1 and 1, X and Y. But we've also got gestures, such as like swipe up, swipe right, swipe down, radial gesture, all incorporated into the APIs. So I want to say, I want to manipulate objects. So right now, this manipulate objects piece is looking like very similar to my spawn object. It's got update trigger info. So I'm just saying, hey, I want to grab my trigger. Am I pulling the trigger? Am I pointing at a game object? Has it got a tag called interactable? Yes. Am I selecting something? Can I scale it with the touchpad? So all I'm saying is, what's the touch force, X and Y on my touchpad? And then I'm doing some haptic feedback onto the device as well. Cool. So I need an attach point on my controller. So let's just add that in really quickly. New game objects. Move that forward a bit so we've got an attach point. Add my controller object to it. And I don't have any selected game objects yet, but let's add that in. So now what we'll be able to do is, once this starts working, is grab our controller, place an object with our bumper, grab the object with the trigger, and as I'm interacting with this, I can then scale it and move it further away from me. So there's my mesh, there's my object. I'm going to grab it. It's now part of this world. And what you'll notice as well, I added this downward raycast, which goes from the object that I have selected all the way to the floor. And this really helps with the understanding of where that is in the world, right? Because it's super hard to tell if this is really far away and huge, or it's really close to us, but really small. So this vertical reticle from the device really shows that if you drop it right now, where would it land? And if I go off into the distance, you'll see that the vertical reticle from the object kind of disappears and only goes a bit. And that means if I drop it right now, it's going to fall forever. Goodbye. So now I can pick up the object, I can scale it, I can move it forwards and backwards along this beam, because I've just changed the attach point. And now I can build my crazy world with big objects and stack them. And again, it even interacts with each other. Cool. How am I doing for time? Very well. So what's the next thing we want to do? We've done all of our controller input. We've used the bumper, the trigger. We've used the touchpad to manipulate the objects. Next thing I want to do is turn off the mesh with some hand tracking. So I'm going to pull in some objects. I'm going to create a new script. Call this, say, hand tracking. And then I'm going to create 3 spheres that match up to my thumb, my finger, and the central point of my hand where my wrist starts. So let's create a sphere, scale it down to be like 0.1, 0.01. And say give it a green fingers. So that's going to be my thumb. I can't spell thumb. Going to say central hand or wrist. And my index finger. Cool. Then I'm going to add my script hand track. Then I need my thumb, my wrist, and my index finger. What I also want to do is, as I do these poses, so as I do a thumbs up or an OK sign, I want to turn off the meshes. So I've got my mesh parent. And then what I also want to do, so when I do an OK, I want to turn off meshing completely, so everything will just fall forever. Or I want to swap between my wireframe mesh or an occlusion mesh. So the occlusion mesh will basically mesh in real time, but won't display that mesh to me so that you can still place objects around. So I've got my wireframe. And then I should have my occlusion. Cool. So what does this hand track script do? It grabs all of my gestures. So OK, finger, open back of hand, fist, thumb. It cycles through and says, which gesture am I doing? Depending on the gesture, I can do whatever in that area. And then what I'm doing is show the points. I'm showing my points, so my 3 key points that I've selected. But you can do 15 points, like I said earlier on. My index finger, my thumb, and my left wrist. What you'll notice here is that I am specifically saying magic leap hands.right.wrist. So if I do my left hand, it won't work at all. It only will recognize my right wrist for this reason. And that's because I'm left-handed, so I use the controller in my left hand, and when I was making this demo, I was practicing my right hand. That's the only reason. So now when I press play, what we should have is everything I've created before. Should have my mesh, my controller. As I put my hand up, you should see I've got my points here, and I've obviously missed one because it's not got my 3rd point. I can fix that soon. When I do a thumbs up, the mesh will disappear. When I do another thumbs up, it's going to come back. If I place some objects in the world, I'm now going to do an OK sign. Oh, and I've disconnected. That's always the problem when you're doing live demos and plugged into your device. Let's restart that. And this will really show how fast serial iteration is to get started, right? So I've just plugged back in because I nearly took my neck off. Oh, this is always fun. Let's close it and open it up again. Yes, cool. So, what was I saying? So yeah, as I do those gestures, I'm flicking between different meshes, and again, doing that in real time. So when I press play again, I'm going to be careful not to smack down and like karate chop the wire. I can rescan my mesh. There we go. I can place my objects in the scene. When I do a thumbs up, it's going to turn the mesh into an occlusion mesh. So we can see, so if I place this object behind here, you can see that it fell behind you. It's disappeared. I could put it down, say, behind this TV. And then now when I move here, it's moving around. Let's place it there. And then when I do an OK sign, it's just going to remove the mesh entirely. Bring it back. And we're back with our wireframe mesh. Let's place some objects. And you can see how the occlusion works in the background there with where you're sitting. Cool. So now, in 20 minutes, we've done spatial meshing, we've done controller input, we've done placing, raycasting, we've done dynamic, a beam, we've done placing the object, we've done object manipulation, we've done hand tracking, poses, and then the next thing I want to do is eye tracking. So when I look at one of these cubes that I place in the world, it should change color depending on the one that I'm actually looking at. So let's add in another object. Let's go on, let's call it eye track. And then let's pull in this eye tracking script. What this is super simple scripts. Again, in update, it's saying, has ML eyes started? So has it got some sort of eye input? It's raycasting from my fixation point, which is the camera. Camera position plus minus the fixation point. It's raycasting from that point. It's checking if an object is interactable. That's what I've tagged my cubes as. If it is, change it to be a different material. If it's not, change it back to be its original material. And that is it, like 60 lines. Cool, so I want to pass in my camera. I want to add in my focused. And I want to add in my non-focused. Let's press play, and hopefully this will work. There we go, we've got our meshing. Let's place it in the world. And you can see, let me scale it up. If I look over here, it's not going to be thingy. As soon as I move my eyes to it, you'll see that it changes color. If I look directly at it but move my eyes to the side, say over here, it's going to change back, and as I move back. So let's place a few more of these in the scene, and we can see as I look around at them, they're going to start changing color. Let's scale some. So again, it's super easy for that kind of accessibility where imagine if someone couldn't use a controller. Imagine someone could only use the eye input, eye tracking, or gestures, or head pose. It means that people can As a developer, you can give them access to different inputs. It means that you can get their eye fixation point. So if they're meant to be looking at a certain area in the room, if they're meant to be looking at a certain object, you could get the analytical data, for example, to do that. We've done a lot of work within our Zurich office, that's our healthcare team, and they've been doing tennis applications for people who need to be more active. And we can get, obviously, headset information of where they're moving, but we can also get eye fixation data to understand where they're looking and how ahead of time that they're looking for, say, a tennis ball. Cool. So the very last thing I want to show you is UI. And some of the best practices around that depends on what you're trying to do as a developer. So we advise basically two types of UI. We've got head-locked UI, which is obviously UI that's, as you imagine, as it would be like screen space UI if you was looking at a 2D screen. But it's further back, it's easier to read, and it's more more instruction-based, I guess, for people. And then we've got world space UI. So I'm going to pull in a canvas here, and I'm going to add in some text. Text mesh pro text. I'll say so here we are. Let's scale this canvas down. We're going to put it into world space. Do that 0, 0, 1 maybe? No, 0.1. And we've got our text here. Let's make that bigger so we can see it. And I'm going to add on this pre-made script called keep in front. So again, this is part of the SDK. And this is a really awesome script to keep this head-locked content close to you, but also interacting with the spatial mesh around you. So as I just scale this down slightly, that's too much. So what I'm doing with this script is, imagine you start an application. You have instructions to the user, but you need them to really understand that this is what they need to do, or it's a title screen. Having head-locked content, but lerping that around, makes the user, I guess it onboards them a lot better. So it means that they're not super stuck to this text everywhere that they look, but it follows them around. So as I press play now and see, you'll see that I can see this. That's way too big. Let's scale it down a bit. And as I say, look at this much closer spatial mesh here, the text will make sure it's always in front. So again, if I look at the floor, it's going to be there. If I move really close to a wall, it will move closer to me. And as I move around, I can set the lerp of this text so that it's not super headlocked, but it's still very visible in my screen. Let's scale it down a little bit more. Cool, and change that to 12. So this is really good practice to make sure that you're not forcing text like super close to the user. It's making sure that you're not making them feel uncomfortable all the time, and it's still within that world space. So again, wherever I look, it's going to start moving towards me. Cool. So that is everything for my demo section. Let's skip back here. And I'm doing really well for time. So as I said, The creator portal is the place to be to get all of this information. So we've got the package manager on there. You've got tutorials in Unity, Unreal. If you want to just go with pure Lumin SDK, you can go on the forums. So our team's always on there answering questions. You can publish. So become a publisher, either a full finished app or concepts. So again, concepts is more R&D prototypes. So they're very small experiences, but a good way for you to either as a user take in different applications and what people are currently building, or as a developer to get your work out there as quickly as possible so you can get people trying it. Here's some more examples of some applications in Magic Leap. So this is a tabletop-based application. It's Angry Birds. So this is made by Resolution Games in Stockholm. And they took the Angry Birds IP and made this a spatial computing tabletop device. So immersive applications, like we spoke about earlier on, can be anything. They can be taken by a full room like this, like Dr. G, which is shooting robots that are coming into your spaceship. Or you can have super simple tabletop applications like this that are physics-based. You obviously fling your bird at the wooden blocks, and they fall onto your table, they fall onto your floor, and the birds fly around your room. It's pretty cool. Or you can have full world immersive applications where you've got this kind of sandbox environment to do a space like this. Tanandi is an amazing application using the music from Sigur Rós, and this doesn't use controller input in any way. It's a mystical forest that kind of develops as you move around it, and you interact everything with your hand tracking. So you move around, and it's very explorative, if that's a word, maybe it is. Sounds about right. That you can move around and interact with all of this forest creatures, with grass, with all of these floating objects. It's really nice. And then think about how we can use characters in this mixed reality space to guide the user through. So this is the experience Dr. G, made by our Weta studio in New Zealand. And this little guy guides the user. It helps them on board with the controller, with the device, with the spatial meshing as well. It's not just us saying, hey, look around the room. It's this guy like, hey, look over here. Come look at me. Come look at me. Come look at me. And as the user moves around, that's what's building the spatial mesh and helping them do that. Because again, if someone just said, build a spatial mesh, they wouldn't understand what that means. So yeah, be sure to check out the Creator Portal. I'm going to be here for the next 2 days, as well as my colleagues. Please feel free to grab me either after this or throughout the Expo. And like I say, I've got my device here if you do want to go. So yeah, please check out Magic Leap Devs. It's a bit early there, nearly. Thanks for that. Please check out Magic Leap Devs. So this is Magic Leap developer-focused Twitter account. And we're doing a lot of content on there aimed at just developers, as well as making video tutorials of a lot of the stuff that we have on our portal. Thank you very much. Thanks very much for listening to me today. I've been Josh Naylor from Magic Leap, and I'll see you around for the next 2 days of the conference. Thank you very much.